Hello children, how are you? Welcome back to our session. So I hope everyone is fine. So welcome back to our session. So in our session, what we are discussing, in the last session what we discussed. So in the last lesson we started our new lesson. So what is that new lesson? What is that new lesson, children? So as we started lesson number 4. So lesson number 4. So what is that lesson name, children? Motion and time. So in the last session, we discussed what is a motion and what is the time. So I hope everyone got an idea. So what is an motion? So motion means an object is said to be in motion. So when you will say it is in motion, if there is change in its position, then we will tell it is in a motion. So if there is change in the position with respect to its surrounding, and when it's said to be in rest, if there is no change in the surroundings with respect to the time. So example also I gave, no. So for example, here I say tree will be there and the car will be there. So the position of the car, it will change. So but the position of tree is in rest, so they will not have any change in the tree's position, but they will be having change in the position of car. So it will move. So it will move from here to here, but the position of tree will be as usual. So here if you are taking an example and if you are telling me who is in motion and who is in rest, means we can easily tell that the car is in motion and the tree is in rest. So in the same way, so I'll give the other example also. For example, boat. So someone is traveling in the boat. So one person is traveling in the boat. So now tell me who is in rest. So who is in rest and who is in motion? So who is traveling? The person. The person is moving the boat. Yeah. So now who is in motion? Yeah, the person. Why? Because he is traveling. He is traveling in the boat. So he is traveling in the boat. The boat is also moving along with him. But who is in rest? So the water is there, no? The water which is there, it is in a rest. So the man who is traveling in the boat, okay, with respect to the bank of the river. So he is traveling in the river. So in the oceans or rivers, so water. So he is in rest with respect to the boat. Yeah. So in the same way, for example, if you are taking as a girl, so one girl is there, she is swinging. Swing will be there, no. So Uyala will tell, no, sir. So that the girl is on the swing. So the girl is on the swing. So for example, this take as a swing and this take as a girl. So moving. So what did the girl who is on the swing? With respect to the seat. Seat means where she is sitting. So with respect to the seat means it is in rest. So she is sitting, no. So with respect to the seat means she is in rest. But she is moving with respect to the garden. Means garden will be as usual. So but she is moving, no. So she will be in motion. So she will be moving with respect to the garden. So in the same way, for example, one girl is moving on a bicycle. So bicycle, she is moving on a, so think this is a bicycle. So one girl is moving on the bicycle. The girl who is on the bicycle, she is moving on the bicycle, no. So she is in motion. And where she is in rest, according to the road, she is traveling on the road. So the road is in a rest. So she is rest with respect to the bicycle. So in the same way, so see, we can tell that. So this is the motion and the rest. So with respect to the time who are moving in our surroundings, that is called as a motion. So with respect to the surrounding who is not moving, so this is called, it is in the rest. So I hope everyone understood till here. So I already said, no, in the next session we will discuss what is a uniform motion. So what is a uniform motion and non-uniform motion? So uniform motion means what and non-uniform motion means what. So in the name itself you can tell that uniform means for example, uniform means not who you are wearing the uniform for the schools, no, that you will not tell as a uniform motion. So we can take it as an example. So how we can take it as an example? For example, if you are wearing different dresses to the school, so every time we are wearing different dresses to the school, is there any particularly you can tell that you are a student of this school? We can't tell. And also uniform means if you are having uniform, that will represent if you are a poor or if you are a rich. But the uniform if you are wearing means then we can tell that. So by that uniform we can't tell no you are rich or you are poor. So that we'll wear the uniform. So we can't we can't tell that, we can't show that. So we can't tell that by that if you are wearing the different dresses means we will be having some guilty. So who are poor, they will be having some guilty that if I am wearing this dress, how it will be. So if there is uniform means there is nothing, so guiltiness will not be there. So everyone is equal. So in the same way, uniform means they will be having certain limit of time. So for example, if your body covers equal distances in equal intervals of time, so in equal distances, equal intervals of time. So I will give an example, don't worry. For example, take a clock. Okay, in the clock, for every fraction of seconds it will change. So for every 5 minutes it will move. So they will be having 5 minutes or till 5 minutes, after 5 minutes, 5 minutes after 5 minutes it will move, no. So they will be having particular limit and particular equal distances. It will traveling equal distances in equal intervals of time. Yeah, so that we can tell it is in a uniform motion. So if your body covers equal distances in equal intervals of time, then it is said to be in uniform motion. And if your body, so if your body means don't take it as our body, so the different one. So if your body covers unequal distances means for example, I'll give two tabular forms so that you can easily understand. So see here children, so I am drawing the two tabular forms. Time in seconds, distance travel, so again time in seconds, distance traveled. Yeah, see here. So here time in seconds means we'll be having 10 differences. I will draw. So I will write. So 10 differences. Here in the first, in the 0, the distance travel was 0. After 10 seconds, he moved 150 meters. After 20 seconds, he moved 300 meters. After that, 450 meters. After that, 600 meters. So in the second tabular form, also same 10 seconds difference. But distance travel was in the 0 seconds, 0 meters, and distance travel was 50 in the 10 seconds. In the 20 seconds, 90. 30 seconds, 180. 40 seconds, 230 meters. So in this we can easily understand by seeing the tabular form only. We can easily understand that here if you are seeing means they'll be having here in the seconds also there is a difference between 10. And if you are seeing in the distance traveled also, so in every traveling there is a difference of 150. So 150 it is difference. So 150, 150, 150. So they are having difference in a equal intervals of time. In equally the distance traveled was there here. So coming to the second tabular form, if you are seeing for 0 minutes it was 0, and coming to the 10 seconds, it was 10 seconds he traveled in 50 meters. But coming to the 20 seconds, he moved 90 meters. Here is the difference of 40 meters. And coming to the here, 90 meters difference is there. So here having a difference. So in the same way, if you are seeing here means we will be having for every time there is a difference of 150 meters. In this, so by this tabular form, we can easily represent that it is in a uniform motion. Means it is covering. So it is covering equal distances in equal intervals of time. But if you are seeing here unequal distances, the distances traveled was unequal in equal intervals of time. The time is same, but it is unequal distances, and the time is same but equal distances. So the time which we are calculating along with the time, so they will be having equal time intervals and equal distance traveled. So coming to the here, unequal distances with equal intervals of time. This is called uniform motion, and this is called non-uniform motion. And also I said first only, so I'll give an example of a clock. So if you are taking the clock means for every 5 minutes there will be change. For example, if a butterfly is there, butterfly is moving in the garden, so it is moving on the flowers. So we have taken the 5 flowers. So can we say that it will be moving on the other in the same interval of time? We know that the butterfly will move anytime she said that, the butterfly said that I'll move in that particular time. So for example, if you are taking an example of a person or anything. So for example, if you are taking a person means only it will be, we can tell that. So we are having an idea. So for example, if I want to move from here to the other place, we will tell that minimum it will take 10 minutes or 20 minutes. So approximately we will tell the time. So but the birds and the animals, where they will be, so in which time it will move, so that we can't tell, no. So that is different. So the second period will be different to that. So if it is for the clock means we can tell that, we can represent it in a particular period of time. So but for the butterfly we can't say. So in this we can tell that example, the clock covers equal distances in equal intervals of time, but the butterfly will not cover equal distance in equal intervals of time. So that butterfly is in non-uniform motion. Coming to the clock, it is in uniform motion. So your homework is, so if you are seeing the page number 31, they have given identifying uniform and the non-uniform motions. So they have given that they are identified movement of hands of a clock. Just now I said it is uniform or non-uniform. Yeah, uniform. So we can write that as a uniform. A boy cycling in a crowded place. Crowded place means, so we can tell that if it is a crowded place means we cannot tell he will move in a certain limit of time. So it is a non-uniform. Movement of housefly, non-uniform. So the fan in an air cooler running at fixed speed. So they will be if it is in an air cooler means they will give a particular limit of they will fix that. They will fix that, according to that only it will move. So they will be having some limit of period. So it is a uniform. A train entering into a railway station. We can't expect. So if it is, we can't expect the train will come in a in correct time. So sometimes it will come before only, sometimes it will come very late. So we can't expect the time of entering the train which is entering in the railway station. That is non-uniform. Kite in the air. So we don't know. So it is non-uniform. Rotation of earth. Rotation of earth means we can tell it is in a uniform motion. So now we are going to discuss the types of motions. So how many types of motions are there? We are having three types of motions. One is translatory motion. The second one is rotatory motion. Third one is oscillatory motion. So we will discuss these three motions. So how it will be. Before discussing the types, so I will give a few examples. Also from that examples, in the tomorrow session I will tell. So what is the translatory motion, what is a rotatory motion, and by seeing the names only we can tell. So rotatory means it is moving, oscillator means what, and the translator means I will tell. So I will give a examples. So from these examples, try to find which is translatory and which is. For example, a car is traveling in the straight road. Straight road it is traveling. So it is in which motion? And also, if you are seeing the fan is there, no? So fan is having three blades. So what motion it is? So how it will move? Coming to the mission means the stitching. So for stitching purpose we'll use that motion of a needle in a running swing machine. And motion of pendulum means if your wall clocks will be there, no? So in the wall clocks also, if you are seeing different types will be there. So some wall clocks will be bell. So for example, if it is a 1 hour, so it will ring the bell, so and it will tell that it is at 12 o'clock, like that it will tell, no? So like that the motion of a pendulum in a old wall clock. So if you are seeing the different old wall clocks will be there, no? That will be. Why I said these examples? So before telling this, I have to you have to know, so in which motions they will be. Yeah. So how we can, so if you are observing the swing machine, how it will stitch. So just these 4 examples I said, no? From that you have to, so in tomorrow session I will explain what are these 3. So at that time you have to tell, so this is in this motion, this will be in this motion, this is an example of this motion. So you have to tell. So in today why I gave you a clue means, so you will observe. So you will observe the fan how it is moving, and wall clock how it is representing the time. So how the pendulum is moving, and also we can't go out and we can't see how the car is moving, no? If you are seeing if you are standing in your veranda, or if you are standing in the balconies also, you can see how the cars are, how the in the streets also, how the cycles, how the motorcycles will move, we can see, no? So just observe how they are moving. Okay, so this I said to observe. So in today's session, if you are observing means, in our session we can discuss it in a easy manner. So in which direction the car is moving. So for example, a cycle or a car, in which, so it is moving in a straight line, or it is moving in a zigzag way. So, and the blades of the ceiling fan, how it is rotating in a fixed line of, it is moving in a circular path or in a different way. Okay, and the needle, so it is moving up and down, it will move, no? So how it is moving? It is moving in a fixed point or in a different way. In the same way, pendulum also. Pendulum in the sense the wall clock, the pendulum in the sense, so how it is moving. So today, if we are observing means in the tomorrow session, we will learn it in a detailed way. So thank you for watching my video. Have a nice day. Stay home, stay safe.